modification in the squirrel cage motor with deep bar rotor construction, or it is called double squirrel cage motor. Look at that. We have the torque equation, and from these characteristics we have seen that what will be the effect of rotor resistance on this torque, on these characteristics, how this rotor resistance affect the torque, right? In the previous topic we have also seen that in squirrel cage motor we cannot alter the rotor resistance, we cannot insert any external resistance in the rotor circuit, hence we cannot change the current flowing through the rotor conductors. In case of slip ring motor, but it is possible to insert external resistance in the rotor circuit to obtain the high starting torque at low starting current, and then we gradually cut out that resistance so that we will get the rated current and rated speed. So this is possible in case of slip ring motor, but we cannot insert external resistance in case of squirrel cage rotor. But however, such a procedure cannot be adopted for squirrel cage, as we have seen, because the conductors in the squirrel cage motor which are permanently short circuited. So in order to provide high starting torque at low starting current, one special type of arrangement we have to make it here. So this is called double squirrel cage construction. So this type of rotor often used for getting higher starting torque. As the name suggests, the rotor of this motor has two squirrel cage windings located one above the other. So which is called double squirrel cage motor. There will be two types of cage or two types of rotor conductors for getting higher starting torque. So look at the arrangement. So you will get very simple, not much difficult. What we require, we have to manipulate the rotor winding resistance so that we'll get the higher starting torque. हे सगळं कशासाठी आपल्याला स्टार्टिंग टॉर्क हायर पाहिजे, मग त्यासाठी ही अरेंजमेंट आहे. डबल स्क्वेरल केज मोटर, याच्यात दोन कंडक्टर्स असतील. लुक एट दिस अरेंजमेंट, यू विल अंडरस्टँड इट परफेक्टली. So this is one part we have considered from the rotor circuit. As we know, the rotor in a squirrel cage motor is nothing but cage where the conductors are made from the thick copper bars and which are permanently short circuit by using end rings. So this is the construction of the squirrel cage induction motor. Look at now. Look at the adjustment or arrangement here for double winding. Now this is a part we have considered. Look at, this is the upper part. This zoom one teeth is zoom here. So look at this. There will be a top rotor conductor bar and the bottom conductor bars. So this is the arrangement. On the top side there will be a conductor which is fixed in that tooth, and in the bottom side there will be another conductor. Look at now what will be the difference of their characteristics. The top bar conductor will have high resistance and the bottom bar conductor will have low rotor resistance. High resistance conductor and low resistance conductor. Simply जे आउटसाइड ला असतील ते कंडक्टरचा रेजिस्टन्स हाय असेल आणि जे आतमध्ये असतील त्या कंडक्टरचा रेजिस्टन्स लो असेल. सिंपल. Only this arrangement. Now look at these 2 points for two conductors. The outer winding, this one, consists of a bar of smaller cross section. Look at this is smaller cross section than the bottom bar conductor. Smaller cross section short circuited by end rings. There will be again end rings are present to short circuit these conductors. Therefore, the resistance of this winding is high. As their cross section is low, then obviously their resistance will be high. Since the outer winding has relatively open slots and a poor flux path around its bar, Look at the outer winding has relatively open slots. So this will be an open slot conductors. And due to that, there will be poorer flux path around its bar. Flux path can be poorer cell because why? The middle conductor is mounted inside the core, and as the conductor surrounded by core, so there will be a good magnetic path as compared to the outer conductors. So it will have poor magnetic path. Hence, it has a low inductance. That's an inductance जो असेल तो कमी असेल, and thus the resistance of the outer squirrel cage winding will be high resistance and inductance is low. So resultant there will be high resistance and low inductance for these outer conductors. Now for the inner conductor, there will be a bars of greater cross section as compared to top bar conductors, and which are short circuited by end rings. So same end rings are there, and which will short circuit that lower conductor also. Therefore, the resistance of this winding will be low because of cross section is greater. Since the bars of the inner windings are thoroughly buried in iron, it has high inductance. As I said, so inside there will be a core, and this second conductor inner winding which is thoroughly buried in the iron core, hence their inductance will be high. Thus, the resistance of inner squirrel cage winding is low and the inductance is high. So resultant what we are getting, the outer conductor will have high resistance and low inductance, and the inner conductor will have low resistance and high inductance, right? So that is what the arrangement inside the double squirrel cage rotor. So hope you understood it. Now working. Look at how it works and how we get higher starting torque by this arrangement. When a rotating magnetic field sweeps across two windings, equal EMFs are induced in each winding. Right? So rotating magnetic field, this conductor will cut that rotating magnetic field, and induced EMF in both of the conductors will be same. Now look at 2 points for two windings. At starting and running condition. At starting, the rotor frequency is same as that of the line or stator frequency, suppose for 50 Hz, making reactance of the lower winding much higher than that of the upper winding. Look at the reactance depends on the frequency. We have this expression, XL is equal to 2 pi FL. 2 pi F. So this equation. So the reactance is frequency dependent parameter. So initially when we start the motor, the frequency of rotor circuit is same as the stator circuit. So that is 50 Hz, making the reactance of lower winding much higher than that of the upper winding. जे आतमध्ये वाइंडिंग आहे तिचा रिएक्टन्स काय असेल मग हाय असेल जेव्हा आपण मोटर स्टार्ट करू त्यावेळेला, कारण की फ्रिक्वेन्सी जास्त असेल. Because of high reactance of the lower winding, nearly all the rotor current flows in the high resistance outer winding. Look at, if this reactance is higher, then there will be reduced current in the due to high reactance in the lower winding. So resultant the much current will flow through the high resistance outer cage winding. So this provides the good starting characteristics of the high resistance cage winding. Due to that high resistance cage winding, so the characteristics of starting will be good. Thus the outer winding gives high starting torque at low starting current. So motor will take low starting current and will give high starting torque. So this is why, because of high reactance in the middle winding and due to high resistance in the outer winding, so there will be a less current in the outer winding, and which will give high starting torque. Now, when the motor accelerates, now gradually in this first point, now motor gradually starting. When the motor accelerates, the rotor frequency decreases. Look at why. When the motor accelerates, so there will be S, which will reduce their value. Right? So the rotor frequency decreases, therefore lowering the reactance of the inner winding. So as the frequency decreases, so there will be lower reactance in the inner winding, allowing it to carry larger proportion of the total current. So it will allow current to flow from the inner winding. In normal operating of the motor, the frequency is so low, it is around 2 to 3 Hertz, that nearly all current flows through the low resistance inner cage winding. This results in good operating efficiency and speed regulation. So this is what the reason. Right? So hope you understood their operation. As we have seen in constructionally, there are two conductors in the rotor circuit. One is at top side, one is at bottom side. The top side conductor will have high resistance and low reactance, and the bottom conductor will have low resistance and high reactance. So what happens when we start the motor? At starting, the current flowing through the outer winding will be greater as compared to the middle winding, because of the inner winding is buried in the iron core, so which will have high reactance. So due to high reactance, the less current flows through the inner winding. So much current flows through the outer winding, so it will have a good starting properties. At starting, we require high resistance in the rotor circuit. So when motor accelerate, what happens? The frequency of the rotor induced EMF will decrease, and as in normal operation, this frequency is around 2 to 3 Hertz, very less frequency of the rotor EMF. So due to that, the reactance is also low, right? So resultant almost all current flows through the low resistance winding or the inner winding. So it will have high reactance, and the motor will run at its rated speed. So this is what the operation of double squirrel cage motor, or it is also called deep bar rotor construction. So it is given in the syllabus that the same point it is given, modification in squirrel cage motor with deep bar rotor construction. So it may be asking the exam. Explain the concept of double squirrel cage motor or deep bar rotor construction. So you have to explain all these points with respect to this diagram. And the starting torque of this motor is around from 200 to 250% of the full load torque. So very large, with a starting current of 4 to 6 times the full load value. It is classed as a high torque and low starting current motor. Then it will becomes high torque and low starting current motor. So this is how we can increase the starting torque for normal squirrel cage induction motor. So this is the characteristics comparison for standard squirrel cage motor rotor and double squirrel cage rotor. Look at percentage slip with respect to percentage full load torque. We have the characteristics, slip increases, torque also increases. At one point it becomes maximum. Look at that thing, double squirrel cage rotor, and this is the characteristics for standard squirrel cage rotor. So it is obvious the normal characteristics, but if you see double squirrel cage rotor, then the characteristics is very exponential around, and the effect of that increasing resistance, we can see it here. Smoothness in the characteristics. So hope you understood this topic.